Hi, and welcome to NVIDIA's Compute for COVID webinar series. Today I'll be talking about our interactive 2010 census plotlet dash visualization accelerated by RAPIDS. So my name is Alan Enemark. I am the head of the RAPIDS visualization team and have a background in data visualization and design. And my colleague here is AJ Thove, who is a core developer in the RAPIDS visualization team and helped a great deal in producing this dashboard. To start, I would like to read this quote from John Tukey, who is a kind of famous statistician and pioneer. It reads, "The greatest value of a picture is when it forces us to notice what we never expected to see." So regarding data visualization, this seems pretty appropriate given today's environment. At its best, visualization is a powerful tool to understand and communicate complex things to broad audiences. And any tool we can help develop that promotes this aim, I say, is a worthwhile effort. So I feel RAPIDS is one of these such tools. It's an open GPU data science platform, so you can do end-to-end workflows of data science all on GPUs. It's Python focused and open source, and is not just one library, but is actually a collection of libraries from cuDF, cuML, cuSpatial, cuGraph, so all working together for various specific workflows in the data science pipeline. So as you can see through this overview, you could use each one of these libraries individually or collectively to kind of go through your generic data science workflow, data prep, model training, visualization, and it all is sitting on GPU memory and GPU acceleration. At the end here you see visualization, which is more of an integral process throughout, but we have several libraries that we have integrated or working with. So our own is called cuCrossFilter, and that's a quick way to build out cross-filtered charts to investigate your data and select and query and have different perspectives. There's also Data Shader, which we are integrating closely with. That is a visualization rendering pipeline. There's, of course, Plotly Dash, which we'll get into more detail in a minute, and then also HoloViews and Bokeh, which are all, again, Python-based visualization frameworks that we're working closely with to integrate with RAPIDS. Now a little bit more about Plotly Dash. Plotly is a company that started with some open source charting libraries and has now created a product called Dash, where it's a Python-based dashboarding and visual application framework. So you can build these complex interfaces and applications in line with your Python analytics workflows without needing a large engineering effort. So when you spec it out all in Python, their tooling basically then hosts it, runs it up, and kind of builds all the middleware backend stuff. And it's all based in Python, which means it can work nicely with the RAPIDS libraries. Which brings us to this general architecture basics, very simple version of it, but essentially you have your Plotly Dash app written in Python that then queries the RAPIDS cuDF data frame on GPU, and all those kind of interactions are scheduled through Dask and then hosted up on a Flask or Tornado server depending on your needs, and producing a web app accessible through your browser and multiple instances of it. So at this setup you can have multiple people querying a single GPU kind of in series, so that you can have an app hosted, one application hosting several individuals, and you can throw it in front of a load balancer, and so that can scale up and down pretty easily as well. So this is all through the Plotly Dash app and a little bit of configuration, and you can have some web scale based GPU accelerated visualizations. Now a little bit about this specific dashboard that we built with Plotly Dash and RAPIDS around COVID-19. It is an offshoot of our original proof of concept, which is starting with the 2010 census data. It's a great open source or openly available data set that we thought would be good to visualize and showcase the potential. And it's a combination of that and the American Community Survey data set. Again, we used it with permission from iProoms, which is a great service. We also have some hospital data from a Homeland Infrastructure program. The COVID-19 data is supplied from the now famous Johns Hopkins University data set on GitHub. And we're using Mapbox as a base layer, of course Plotly Dash, data shader for the high density population rendering, and cuDF and cuPy for RAPIDS. So with that, I'd like to jump into a live demo of the visualization. So as you see here, we have our app hosted, running through Python servers, and available through any modern browser. Right now it is showing the US population of 308 million individuals, and this is using data shader to render that on a map. So each individual is plotted as a point and aggregated up. So we can do quickly zoom in and zoom out, and you'll see it re-rendered here. So the current color mapping is actually of age. So the lighter purple is for younger demographics, and the darker blue is for older, based on the scale. And so very quickly as you zoom in, you start noticing these kind of hot spots for older demographics. So quickly you can see there's something called Leisure World. I've looked it up. It's actually a retirement community. So very quickly we're able to find that within LA and say if we're concerned about COVID-19, some more vulnerable populations, we can kind of select that and see these different regions and zoom in and out. Because the GPU enables this to render and be queried so quickly, it really encourages me to just kind of pan around and see the patterns and investigate the data like at the speed of my own thought and curiosity. So that's something that is really taking advantage of the GPU acceleration, in this case with population maps. And of course we can change the different color scales. In this case now it's just a population density, so you very quickly see where the major cities and urban centers are. Now below we have line charts of all the US states and the total COVID cases over time. When we started building this application, you can see how each state is doing compared to one another and interact with the total case count. It is pretty telling to see them all together. And of course we can also toggle between total deaths and different scales. As I mentioned, because Plotly Dash is more of like a web application framework, all these filters and views can be customized and queried per your particular needs. So these aren't like hard-coded queries at all. So with this we can overlay COVID data. These are obviously mapped as large bubbles. I'll go in a bit more detail later on about pros and cons of different charting types, but right now this is showing 4.7 million cases throughout the US total. We can zoom in, and these are all per county, like I said, from the Johns Hopkins University data set. We can additionally overlay hospital bed counts. Early on when we're building this, that was a major concern. So this is showing all known standard hospital beds, about 1 million. So within the total US population of 2010, total current COVID case counts as hospitals. You kind of get a people to bed ratio for the whole US. Now with the, again, power of GPUs, we can query this fairly quickly, so then I can roughly select Florida and see how they're doing for total cases, so of a population of roughly 20 million. We have a pretty good people to bed ratio and total case count, but then if we like zoom in and try Seattle or Washington State, we can get a rough count and a much higher people to bed ratio. And that alone is able to see the different regional differences very quickly and interactively. Now, like I said earlier, we can change the different views on through this drop-down. So now we can see new daily cases, where particular hotspots are. Looks like Los Angeles County is still having a lot. Or we can say cases per capita by county, and it's a totally different perspective, where you can see kind of general regional clustering happening here as well. So very quickly you can see a national level, toggle different views, zoom in, see how a region's performing, and then do queries around that view and interact with the data kind of in real time. And this is all running on a single desktop GPU. In this case, it requires 16 gigabyte GPU, but again, the more attributes or less, it varies. But again, this is hosted on a single GPU on a local desktop, so pretty accessible. Now I'd like to go a little bit more into the data and design process we went through for this visualization specifically. And as always, it starts with just understanding your data and sketching. And by sketching, I mean physically pen and paper as much as possible. First off, getting to understand the data means learning what attributes are important, what are available, the counts, distribution, things like that. And then very early on, trying to map those out, especially if your end kind of goal is to create a visualization, trying to map those out in effective ways. And so you can see my early sketch here. It's kind of similar to what we ended up with, but doing it on paper versus going to even your favorite visualization tool just enables you to go through that iteration much faster without the kind of technical overhead of using your tool. So the opportunity cost is very low, even if you're sketching poorly, to kind of run through a couple of ideas without ever having to code or select a GUI thing. So that way you can kind of get to a more matured visualization even faster than you normally would with without sketching. And of course, it's a back and forth process. As you find more about the data, you have to alter your views and chain it out. And it's also a very effective way of communicating goals to other developers, who are helping you build these dashboards, versus just sort of, waving your arms around. And this is just indicative of the data visualization process, which is always highly iterative. The more you know and develop, the more you kind of react and change out your dashboard. So while we began with deciding to use the 2010 census data and realize it's down to the block view, we decided in order to really showcase the power of the GPUs, we wanted to show the kind of visual impact of mapping individuals and the fact that the GPU is able to do that. So we took the liberty and kind of randomly placed individuals from those counts within those city blocks to kind of, again, get that visual impact. And then early on we decided to prototype with our QX filter library just to get a sense of, again, the distributions and if the lat long mappings are accurate and if those random placements within city blocks made sense with the data. And it's great to do that early on versus spending all the effort in a tool to build it out and then realize your data mapping or chart selection isn't going to work with the data, and then you're kind of starting from scratch. So it's Quick filter is great for that type of quick early on prototyping and data investigation. But then once we went to that and started building out the census data, census visualization, COVID-19 started really ramping up, and we were asked to see if we can use that census demographic information to help with various stakeholders in combating COVID. So that's when we pivoted to developing this COVID visualization, went through several iterations until landing to what I just showed you. Now, again, there's pros and cons to different types of visualizations, and it's always a balance between hardware, data size, performance, and design goals per your audience. So given that we're using 2010 census data and it's a national view, our focus was then to design a tool that was kind of nationally focused, where you could then very quickly zoom into very highly regional and city block views. So that sort of dictated a little bit of why we designed it the way we did and what we ultimately came up with. In addition, using the bubbles, while it's actually kind of tricky based on how varied the scales are of case counts, we still felt that was better than, saying, highlighting a county view where you can have a small county with a high density of population, which not be as apparent, versus a large county with low population that would be kind of very visually apparent even with high case counts. So that's kind of the give and take. We stuck with the bubbles, but that's kind of a thing that is an interesting ongoing debate within the visualization community about the different best practices, and it's been actually really reassuring to see how quickly that's evolving online and through that community with best practices. And of course, the benefit of using a tool like Plotly Dash means that you can react to these best practices and deploy them out into your dashboard pretty quickly. Because again, it has a JavaScript front end and React front end, and with a wide variety of charts, you get broad customization for all kind of aspects of your dashboard. And that's because Dash is not necessarily just a dashboard builder, but it is a proper web application framework. And again, utilizing GPU acceleration and the data shader framework and encompassed with Plotly Dash as kind of the overall app, you're able to really work with this high fidelity data in ways that you weren't able to before. And so zoom between national aggregates to individuals and everything in between, and see how these new patterns relate to one another at different scales. So you really end up spending more time exploring the data rather than just processing or waiting for queries. You can kind of explore at the speed of thought, as we like to say. And this is really due to the fact that the GPUs enable real-time interaction on even very large data sets. So you're not dealing with pre-aggregates, or you're not, as I like to say, pre-validating each interaction. So that leads to some things where if it takes 1 second to do something, you're more apt to do it because the opportunity cost is low, versus say 10 seconds or 100 seconds or more, right? It's sort of the thought of using a really slow computer and how frustrating that can be, and it discourages your ability to interact with it. So, if, as I'll show in the next quick video, a query takes 50 seconds to run, I am more apt to try to say, well, this is the query that'll show something that will be interesting, versus look, this takes 0.3 seconds, I might as well just check if something interesting happens or not. So you can really run through those iterations. And again, this is done on a single GPU, but if you want more attributes, more features or things like that, you can scale it up with multiple GPU support in the future. So this is a quick video we developed prior to the COVID dashboard as, again, the census version of the demo, and you can see it has different attributes such as income, age, education, and class of workers, as well as, again, the individual rendered data points. So right now we're selecting Florida. It's taken about 0.3 seconds. We querying the different age distributions for this region. Very quickly notice there's a slight bump in these like 17 to 20-year-olds. So cross-filter that and zoom in to see where kind of those clusters are. And let's zoom into Tallahassee here. We see it's still clustering. We keep zooming in. As we're rendering the individuals into blocks, we can see that this is even clustered further. And right now we can zoom in and see, well, that makes sense. It's Florida State University, where most of these young individuals are residing. So, there we go, confirm it. Very quickly, we had an assumption that Florida is an older demographic, but then found this younger demographic, which are from, external students coming into their school system. So what was something that very quickly we found a potentially interesting pattern. We selected that and we zoomed in and were able to kind of validate hypothesis. Because each of those interactions was so quick, we're able to do that fairly short order versus now, as you see, if toggled to CPU mode, even just getting the exact same initial query in that state is going to take a long time. And so this is the difference between using cuDF, which is our GPU accelerated framework, versus your standard Pandas, which is a CPU kind of single-threaded approach. There's different techniques you can use for either, but basically this is the most apparent with using GPU versus CPU. And I'm going to keep showing this video just to show how painful it is to wait for a single query. So this took 47 seconds. On CPU or GPU, it takes 0.3, right? So one is definitely going to encourage you to investigate your data more versus the other. And this is because really you have access to this powerful compute engine known as RAPIDS and tying that to a very customizable front end. So all through Python, this means you can run arbitrary calculations of functions right from the GUI. You can chain a bunch of them together. You can do some pretty complicated things in complex processes, even by just through tying them together to a button click, right? So this is where something that you'd use a data scientist to create this whole pipeline. You can then turn that into this Plotly app, and have it available to a more broader audience to run these complicated compute things. So this is an example of a code snippet to run this app. As you can see, you have custom function calls, and you're able to be very customized with it. It's all Python based. There's also notebook integration available. The drawback is it can be pretty verbose, especially if you're not only selecting or describing what functions you want to call, but also what charts, the layout, the colors, that sort of thing. So it can get pretty long. But as Plotly Dash is part of the NVIDIA Inception program, we are working with them very closely for improving integration and developing more succinct syntax in the future. That being said, Plotly Dash isn't ideal for very quick prototyping, as we described before, but it does allow for going quickly from your development of a dashboard to production and web scale, basically using the same code base. So you kind of make up for time there. So you can see all this yourself. It's the benefit of being an open source project with RAPIDS and also Plotly. This is on our GitHub at RAPIDS AI, Plotly Dash census demo. This is both the census and COVID-19 branch. Please take a look at it. We encourage you to play around with it as long as you have a GPU that meets the spec. And it's pretty easy to install if you have Docker, Anaconda. All the data sets are public as well, so it'll download automatically and you can try it out. Very briefly, I'm just going to talk about some of the lessons learned and potential next steps. So as we were talking to different stakeholders as we're developing this, it turns out a lot of them were pretty interested in those very specific demographics attributes. So in future or with updated versions, we're hoping to include those again. Incidentally, aside from the population data, the actual COVID data was relatively small to take full advantage of the GPU acceleration. So in some senses, integrating the two more tightly together would be a better use case. And additionally, like I mentioned, this tool was kind of built with a national level focus, but as we talk to people, it's been a very highly regionalized response, and so it's not necessarily the most useful for some of the stakeholders we were talking to. That being said, one potential great use case would be to really leverage the GPU to take this high fidelity population data and use it for modeling spread visually, because to date most models have just been about case counts, and to be able to really see how those spreads could happen visually could be a pretty compelling use case. And of course, using updated census data would be fantastic. So with that, these are a couple of additional resources. You can learn more about this project and dashboard. It's on our rapids.ai/plotly page, or the Plotly announcement blog, or our detailed blog about how we developed the census demo and formatted the data from that. Again, these are all accessible through rapids.ai. Or if you don't want to install it yourself, you can try it online with a different version of a 150 million row Plotly Dash and Rapids app using mortgage data on the Plotly Dash website. So with that, thank you for viewing this webinar and your interest in Rapids and Plotly Dash. We hope to keep developing more proof of concept demos and improving it in the future. Thanks so much.